So when I talk about friction, right, if I have to give you a basic block diagram structure of understanding how it works, can you give me a summary that what did we do yesterday? We took an object. In fact, we took two objects, rubbed one against the other, right? And we could see there was some charge that got generated. Okay, you saw this phenomenon. Now, if I put a question like this, can you try to give me an explanation of science behind it? How you put it? So, rubbing one object against the other, you did it. When you use the word against, you use the concept of friction. Okay, friction is there. But how did friction help the charge to get generated? Sorry? It in the form of. So, I told you one point yesterday. Wherever you think about charging, what is the first thing that should come to your mind? It is an atom, right? Electrons are lost or electrons are gained. It's going to decide whether the material is charged or not. As simple as that. We need not think anything outside that, right? So for me to make the material get charged, what am I supposed to do? I either need to increase the number of electrons or decrease the number of electrons. So for that electron which is present in the outermost orbit, if I am able to supply some sufficient amount of energy, then I can always make it escape from the surface. Are you able to understand what I'm trying to say? See, you would have learned photoelectric effect, right? So what does it state? If I have an electron like this, what does photoelectric effect state? Photo refers to light. Electric refers to charges, right? Okay, electron charges. And effect is some phenomenon, right? So what does photoelectric effect state? If there is a light of sufficient energy that is illuminated on the surface of some material, then you can think of making that electron escape from the outer motion. Right? In a similar way, instead of using light, if I'm able to use heat energy, then you can make this electron escape. That kind of an emission is called as thermionic emission. Therm refers to thermal. Ionic is when an material loses or gains electrons, it becomes an ion. Right? So what exactly is happening here is through friction, the first thing, right? If I put a block like this, through friction, what is that you're able to generate? Heat. And what is that heat actually able to do? Make the electron get escape from the surface. Right? Either of the materials which are in contact should lose and the other one should gain. It's a relative constant. Okay? So due to this heat, what will happen? There is a charge that is created on the material. Makes sense? Right? So if you have to give a simple block diagram structure of what happens through the process of friction, this is all looks. Here, right? You can make a note of it. Getting it for? Okay. Right? Shall I proceed? Now the next question is about induction. So yesterday itself I told you induction means without any physical contact. Okay. So if I take, let's say, a spherical object in my hand, and if I call it to be neutral, so what is the meaning according to you? What is that your understanding from this? So it has same amount of positive and negative charge. Suppose, let's say through friction I charge this material, and I'm taking this material and keeping it close. I'm not touching it, I'm keeping it close. Like if you observe from the yesterday's activity that we did, we saw that the charge was created on the plate. But where did those materials come from? They came from the bed. They came from the bottom, right? What happened actually? So this charge created a field around it. Due to that field, what happened? There was a charge induced in that small aluminum ball, right? So what exactly happened is, let's say I have a charged material like this, right? And this material is neutral. What are we doing? We are taking it close. So if suppose the medium is conductive, right? If these objects are able to interact with each other. Let me put it in this way. Right? Means what will happen, this positive charge will have the capacity to exert a force on the neighboring atoms. Right? Due to which, let's say it has some charge. Can I say something like this happens? What did I do? I have 4 positive charges, 4 negative charges. I just redistributed them. So here if you observe, this material is not charged. Why? Because if you move this away, what will happen? If you use the additive nature of charges, still this material is neutral. Right? So if I move this away again, still the material is going to be neutral. I cannot call it as charged. Right? So through this, what you did is you created not a charge, rather redistribution of that. What did you do? You actually redistributed the charge. Right? That is, you brought complete negative charge to one side and the complete positive charge to the other side. If I have to give you a similarity, think of a battery. What does it have? It has a positive and a negative end, right? So it's something similar. Right? So the charge has got redistributed. So to make this material get charged, what am I supposed to do? I need to make either of the charges get lost. So I need to either completely remove the negative charge or remove the positive charge so that I can call that object as an isolated charge. Right. For that, what we will do is you take this and connect it to the ground. Right. You know this process, right? What do you call it as? You call it as earthing. When you do this, what will happen is the excess amount of charge that is present this side will start flowing to the ground. When this happens, what is that you are left out with inside? You will be left out with the negative charge. Right. Now you can say that this material is charged. But how did you approach this and bring the output? Without any physical contact, by attaining charge on a material through this process is what is called as charging through induction. Are you able to understand? So please make a note of it.